So are we recording? Good. Excellent. So Shannon, take it away.
All right. Thank you. As Sean mentioned, I'm the new president for the Chesapeake chapter this year. And for a talk today, I thought I would talk about maybe some trends that I'm seeing in systems engineering. Maybe not new trends in terms of the discipline, but definitely a hiring demand, maybe emerging trends from this, and give a little bit of my thoughts in terms of, being a hiring manager in some of these areas. All right. So let me flip. So in terms of an agenda, I'll just go over a little bit of the objectives for this talk. In terms of trends, I'm going to touch on model-based systems engineering, digital engineering, AI ML, agile systems engineering, and human-centered and systems engineering. And then I thought I would end with just some general hiring observations of systems engineers and some commonalities of at least things that I look for in acquiring new talent, regardless of maybe their subset skill. So in terms of this talk, I'm hoping to enable some discussion on systems engineering competencies that I'm receiving a demand for as a manager. This is really based on just kind of observations from my experience. I have it broken up into the 5 different sections per trend, and I thought I would just do a quick overview just to make sure everybody's on the same page. I'm sure majority of people are familiar with most of these topics, but at least give out a couple definitions, a little bit of how that trend relates to more traditional systems engineering, some goals of the trend, and then specifically to hiring, skill sets I look for, and things in terms of understanding I look for in a candidate. And just as kind of a disclaimer, I am not an expert in all these trends. And this is more from a hiring manager's perspective. I try to know enough about each of them so I can hire the skill sets for my team. I also say throughout this talk, if anybody has any questions or has any of their own thoughts, I welcome them. I'll try my best to monitor the chat, but feel free to interrupt and speak up. I think that this will be more valuable hearing from other people's perspectives as well. All right, so starting with the first one, model-based systems engineering. I think many people know the NCOSE SE Vision 2020, or sorry, it's the NCOSE Systems Engineering Handbook, 5th edition definition, but the thought is MBSC is the formalized application of modeling to support system requirements, design analysis, verification, validation activities, beginning at the conceptual design phase and continuing throughout the development of later life cycles. I don't know from other people's experience, but from my own experience, I would almost bold the system requirements and maybe design analysis in terms of MBSC. I think there's a lot of effort that is done in terms of requirement elicitation and architecture design in MBSC, and starting to see more of the verification validation activities. But um, I think SysML as a primary language is really good at doing the requirements and architecture definition. Obviously, we have our 3 pillars of MBSC, so you need 3 things. In order to execute model-based system engineering, you need at least a modeling language, a modeling tool, and a modeling methodology. So these are 3 things I look for, obviously, when talking to potential candidates who would fill an MBSC role. In terms of MBSC and more traditional systems engineering, MBSC is a modern approach for systems engineering that really emphasizes the use of models to capture, analyze, and design and communicate system information. And this is meant to be throughout the system's life cycle. So in an MBSC approach, what we're doing is we're using a descriptive model to capture, analyze, and share information associated with the specification of a system. And the idea is that a systems engineer can effectively and efficiently adapt to changing requirements and design quickly. The idea with, you know, um, MBSC, elements and relationships. If you trace everything properly, if you make relationships between elements properly, if you change one thing in one part of the system, that's going to trickle throughout. You can easily see the down, you know, the down effect of a change, in requirements of how that affects your design and later things. So in terms of why you might want to do MBSC and why a customer or a sponsor of a project might be asking for an MBSC, you know, specialty type of engineering is improved communications among the development stakeholders, um, an increased ability to manage system complexity by enabling the system to be viewed by multiple perspectives, improved product quality by providing an ambiguous and precise model of a system that could be evaluated for consistency, correctness, and completeness, reducing risk by surfacing requirements and design issues early, and then reduce cycle time of design because you have better control of your technical baseline. You can do more rapid impact analysis, improve specification and design reuse, and having that early insight into design decisions, and early discovery of potential defects. So, how I get to the point of needing to hire people with the MBSE skill set, I think comes down to these goals of, what customers or sponsors of programs are looking to achieve by implementing MBSE within their program. All right. So then in terms of hiring, so we talked about the three pillars: the language, the tools, and the methodologies. So you can evaluate a candidate's skills, their proficiency level in a language, a tool, or a methodology, or multiples. Um, Ideally, especially if you're hiring more at the senior level, ideally they would have multiple languages that they understand and multiple tools, as well as methodologies that they can tailor, because obviously, there are different project constraints or different reasons why you might use different languages or different tools, or approach the MBSE execution with different methodologies. And then also, like I said, because MBSE is heavily used during the requirement and architecture phase, that understanding of how to do architecture and design in a model form. So when I think about a candidate and looking at resumes, and maybe doing a phone screen type of thing, I really try to understand how much they know their language, the tool, methodology, because not everybody's going to have the same proficiency in each thing. For my own projects, I really look to see that they know the methodologies and how to tailor those methodologies, because at my company we have enough time to be able to teach a language and a tool, depending on the company. However, if you're hiring for a specific um, project or job and you already have the methodology under control, maybe you just need somebody who knows some of the tools. How important are MBSE related certifications in the hiring process? So I think if somebody has like an OMG certification, I'm really confident that they know the language well, depending on what level they have. So I think having those certifications, we're not going to ask as many questions about, maybe the language or even maybe a tool, because the OMG certifications already assess somebody's knowledge on, I think, SysML 1.4. So I don't think, to get in the door at my company, you don't need the certification. However, it might make your resume stand out more, and it also might reduce our interview questions a little bit because we're already pretty confident that you have that skill set. And then I think, it's one thing to evaluate skills. I think the tricky part with hiring is really trying to understand the candidate's understanding. So it's not just like the academic pieces of things, or knowing a specific skill set, but do they know why they're doing something? Or if they're thrown a curveball, like with their skill set, would they be able to handle it? So thinking about that a little bit, in terms of evaluation of candidates' understanding, a big thing for MBSE and any sort of modeling is understanding the purpose of your model. So typically we're not just modeling for the sake of it. There are some questions you're trying to answer or something you're trying to discover or uncover. So if somebody can give me different examples of how they really tailored an approach to meet a purpose of a model, I think that really tells us that they have a deeper level of understanding. Knowing how to elicit project constraints and stakeholder needs. So obviously every project is different, every stakeholder is different. You have to understand what they're hoping to get out of by doing an MBSE approach, so you make sure you hit the mark. So there's examples of how how they were able to get some of these stakeholder needs and really understand the project constraint and know what that means. That's also a good sign for a candidate. And then, of course, experience with tailoring the language. You can tailor some tools and obviously tailor a methodology to meet the project's needs. Just because something worked on a previous project doesn't mean it'll work on every project. So I think it's really important for somebody to explain what they did and why that worked or why that didn't work, because I think that shows some growth. In terms of methodologies, so methodologies are more like, how do you know what steps to do as part of the process? So an example of that is the object-oriented systems engineering methodology that actually the Nkosi Chesapeake chapter published a while ago. Another one is the Dassault Magic Grid methodology, which looks more of it in terms of like a black box, white box implementation kind of set. I don't know if anybody on the call has any other methodologies. Those are the two I primarily use.
Yeah, I'll add.
Yeah, go
Right.
ahead.
So like methodologies, like it's interesting because I think some people confuse that with like modeling frameworks, and like some of these, methodologies kind of also getting pulled into like, I think UAF has like I think it was like a 6-step like model development process that's also tied to it. Um, the reason why I kind of mentioned this is like, to some degree, when we interview, we can elicit that information from somebody. But that last bullet of like tailoring the language, like I've seen so many people where they have clearly understanding of the details of the framework and know what to put in the model. They don't always know why they're doing it. They've often had like some other lead systems engineer help guide them, or they're just kind of winging it. And so I think being able to tailor, right, the approach that's taken and knowing a lot of different approaches has been very important to assess.
Yep, great point. So, framework knowledge is also good to have. We usually don't explicitly ask about frameworks unless it comes up. But obviously, UAF for more like it's I think important for people to understand why a framework was developed, what the purpose of the framework is, what are the trade-offs with using a certain framework? Do you have to tailor it? For UAF typically being like mission engineering level things. So that sometimes comes up in our interviews depending on the role we're looking for. But typically, if somebody has already been able to demonstrate that they can understand how to follow a methodology and tailor it, taking that step forward into a framework once we take some time to explain what frameworks are and how to use them isn't a far step. All right. Any other comments on MBSE before I move on to digital engineering? All right. I think MBSE has been a pretty interesting area to hire in because there still aren't a ton of people, I think, out in the community that aren't already employed at a company that really have all three at a high proficiency level with the language, the tool, and the methodology. And I think also, right now, at least in the spaces I work in, Cameo is the prevalent tool. And a lot of people have experience, but at least at my company where we act as more trusted agents for the government, we have to be able to know enough about other tools to provide the right recommendation. And I also think with SysML2 coming up and all the tool vendors implementing things different ways, we're going to have to do a relook at the tools. So I think it's really interesting when you get somebody who knows more than one tool because they tend to understand the language a little bit better because they know what was a tool implemented thing versus what is really truly part of the language spec. And also, what is truly a SysML compliant tool versus not. So something I think to look into if you're either hiring somebody for MBSE or want to become, really proficient in MBSE is just some things to think about. All right. So next, digital engineering. So per the DoD Digital Engineering Strategy Guide, digital engineering is the integrated digital approach that uses authoritative sources of systems, data, and models as a continuum across disciplines to support lifecycle activities from the concept to disposal. So digital engineering obviously isn't systems engineering. It's a much broader thing, but as we're finding, systems engineers, I think, have a key role in defining and help understanding what digital engineering is. And then obviously as part of engineering, the systems engineer has a role in a digital engineering ecosystem um, when a project is developing their design and concept and everything in a digital manner. So in terms of digital engineering and systems engineering, we just talked about model-based systems engineering. Obviously, in model-based system engineering, you're building models that could be used to inform other parts of engineering or other models. So if you're already going to do something in MBSE format, you already are, maybe a step into participating in a digital engineering ecosystem. Then digital threads, which is a connected framework that enables traceability and integration of system information throughout the life cycle. So I think there's been a lot of work with digital threads in systems engineering because as systems engineers, we interact with a lot of different stakeholders. We interact with a lot of different engineering disciplines. So we're in a position where we see a lot of those interactions, see a lot of those roles, and how people do their jobs, what type of data they use to make decisions. So I think we've, as systems engineers, have been able to help define some digital threads and show some, at least prototypes of it. Digital twin is a real-time virtualization of physical system that's used to monitor, simulate, or optimize. So again, like a digital twin, something that's really important is understanding what the purpose of your digital twin is. That can give you some ideas about the level of fidelity you have. Digital twins, I don't think are typically systems only, but definitely systems engineers help inform some of the digital twin things from the descriptive modeling. Simulation and analytics. So, tools for any early validation designs or performance prediction or decision support that you might do kind of fall in this digital engineering bucket. Then a big kind of item in digital engineering is known as authoritative sources of truth, which these are digital artifacts that originate from legitimate sources and is valid for given uses as proclaimed by an authoritative entity. So I think understanding what the authoritative sources of truth are for your project and how to use them and how to either add to them and get that data validated or get the legitimate information you need to do your next job is another piece from systems engineering. And then we have the adaptive acquisition framework. So this is more of a US DoD type of thing, but it's a series of acquisition pathways that enable the workforce to tailor strategies to deliver better solutions faster. So rather than just doing kind of the ACAT 1 sort of acquisition, they have different types of acquisition for prototyping or middle tier. So it's an attempt to make sure we're keeping the right amount of systems engineering rigor and understanding the maturity of our system in acquisition, but trying to allow some flexibility and maybe how that looks and some timelines. So it's not always serial. It's not always you have these superficial gates that take time. There is a place for just doing some prototyping and delivering, and also some middle tier kind of acquisition. All right, so why would you want to do digital engineering, or why would you want to hire somebody who has this digital engineering skill set? So the thought with digital engineering is that there's improved collaboration because you have digital models that provide a shared and interactive platform for communication across disciplines. There's enhanced decision making because we have advanced simulations and analytics that enable some rapid exploration of design trade-offs and what-if scenarios. Increased efficiency with automation of processes like requirements traceability and validation to reduce some of those manual efforts and errors. And then finally, lifecycle integration with digital threads to ensure that the data is consistently shared and accessible across the lifecycle stages, which should improve your traceability and reduce risk. So in terms of hiring for digital engineering, so this is a newer thing we've been looking at as opposed to model-based system engineering, which we've been doing for a while. But evaluation of the candidate skill set. So, in digital engineering, you're using tools, more broadly than in MBSC. So, you have to have awareness of, program management tools, risk tools, system engineering tools, and other tools you might be interfacing with. So we try to evaluate that type of knowledge. We have a lot more digital data in digital engineering. So making sure you have a full understanding of the configuration management, how we're using the data, any sort of metadata associated with the digital data is an important thing that, your candidate understands how you would go about doing that, or maybe has some examples of what's important to capture. And then engineering process integration. So in digital engineering, we're trying to be able to do things faster without increasing risk. So we're still following engineering processes, but we're trying to integrate them digitally so that you remove some stovepipes and can realize things a little bit faster. So we usually ask or look for skills on a resume that kind of indicate that a candidate knows how to do that. And then in terms of evaluation of a candidate's understanding, so because a lot of things are in model form, the ability to evaluate when a model is a representative for a given purpose. So you have to understand why you need the model and the level of fidelity it needs to be at to meet its purpose. Not everything has to be super high fidelity. It really depends on the types of questions you're asking. Assessing the stakeholder needs of engineering teams. So in digital engineering, if your job as a systems engineer is to understand the digital engineering ecosystem or to build a process around that, your stakeholders become the different engineering teams that have to actually, build a system within this digital engineering ecosystem. So being able to assess the stakeholder needs is something we usually have a line of questioning about. And then kind of going along with that, understanding the role of participants in digital engineering ecosystem. So how the different roles need to receive data, when they have to receive data, and how they're going to use that data is an important thing for a candidate to understand. So I'm going to pause here for a second. Any additional comments for digital engineering and hiring that skill set? All right. So with the, ChatGPT being more usable as of 2022, the artificial intelligence and machine learning has become something that we've been looking for and something that we've been at. So starting with just some definitions for what is artificial intelligence versus what is machine learning. So artificial intelligence is the study of agents that receive precepts from the environment and take actions that maximize their chances of successfully achieving their goals. And then machine learning is kind of defined as a program is said to learn from experience E with respect to some class of task T and some performance measure P if the performance at tasks in T as measured by P improves with experience E. So some of the things that we've been looking at in terms of system engineering and artificial intelligence and machine learning has been more in the machine learning kind of category of how do you learn from existing documentation, learn from questions that we're asking to produce better results. So how can AI ML help with systems engineering? So some of the thoughts is with requirement engineering. So it could help streamline the process for gathering, analyzing, and managing requirements. Natural language processing tools can also help with the automation of analyzing the stakeholder requirements, and especially with detecting inconsistencies with requirements. So when you have a large set of requirements, maybe each requirement in itself is verifiable, testable, understandable, all those type of things. But when you start to aggregate them, maybe they don't work as a set. And the idea is that AI ML can help with some of that. AI ML system design and integration. So the ability to design architectures that integrate AI ML components into the system. So this is more AI as part of your system, and what does that mean, and how does that integrate with more traditional components, and also how do you V and V a system that has AI ML in it, especially if it's non-deterministic. So if it's learning while it's operational, how do you make sure that you're still following all the certain requirements you have, especially in terms of safety. Testing, validation, and verification, improving the efficiency and accuracy of testing and validation process. And this could be done by automating the generation of test cases, identifying defects, and optimizing testing strategies. And then AI ML is also pretty good at doing the continuous monitoring and system optimization. So supporting monitoring and adaptive optimization of systems during operation. And using AI ML can dynamically adjust to changing conditions and optimize the performance. So in terms of goals of what AI ML can help with in terms of system engineering. So one of the ideas is enhanced decision support. So with AI ML techniques, enhance decision making in systems engineering by providing some predictive analysis, identifying patterns, enabling real-time data analysis. These tools can support engineers in optimizing system performance and addressing design trade-offs. Handling complexity in large-scale systems. So as systems become more and more interconnected, managing this complexity is critical. So AI ML can help engineers simulate, analyze, and design large-scale systems with independent components. Predictive and prescriptive analytics, AI ML can help enable predictive and prescriptive analytics by helping engineers anticipate system failures or inefficiency and maybe recommend some optimal solutions. And then finally, autonomous system and human machine collaboration. So AI ML enables the design and integration of autonomous systems that can operate independently or in collaboration with humans. So systems engineers, as part of this, would be tasked with ensuring that those systems are safe, reliable, and effective. So then going to hiring systems engineers with the AI ML skill set. So in terms of evaluation of a candidate's skills that are unique to AI ML, obviously the artificial intelligence, machine learning fundamentals, it's not expected that a systems engineer with a focus in AI ML is an artificial intelligence or machine learning, researcher or even expert, but they do need to be able to talk with those people to understand, how the algorithms and things can be integrated into the system, how could it help you do your system engineering job, what are the limitations, when you use one approach versus another. So having at least that fundamentals really gets them a head start there. Some software development skills. So typical programming languages that are used in AI ML are things like Python, R, MATLAB, or Java. They're commonly used in AI ML development. So if there needs to be some sort of, algorithmic development to implement or optimize algorithms for a specific system need, this can help, if they already have that kind of skill set. And then data management analytics. So, data engineering in terms of managing data pipelines, the big data tools. So familiarity with managing and analyzing large data sets, and then data management, proficiency in working with, databases like SQL or NoSQL for AI ML applications are types of things that we look for in a resume when hiring a system engineer that's maybe has an AI ML focus. So then, during the interview, trying to evaluate their understanding. I think it's really important to understand the challenges when using artificial intelligence. So, there's some examples of challenges are, data dependencies. So if you're going to have effective AI ML models, that requires a large, high quality data set. And depending on the system that you're building, that might not always be available. Explainability, ensuring that the AI driven decisions are interpretable and transparent also is a significant challenge. Ethical considerations. So, AI ML systems must be designed to avoid bias, ensure fairness, and prioritize safety. So that needs to be especially in the forefront of somebody's mind if they're building a system with safety concerns, as most have. And then integration of AI ML into existing engineering workflows, requires a fairly robust infrastructure and domain expertise. So being able to explain what that means and maybe propose how they would incorporate AI ML into an infrastructure that doesn't currently have that, or what their needs would be something we'd be looking for. Proficiency in validating AI ML models. So we need to make sure that the AI ML models are accurate, reliable, are aligned with system goals. So as part of that V&V, especially in non-deterministic AI ML sort of algorithms, we need to make sure that if we're using it within a system, we can trust it. And then because this field in particular is moving at a very fast speed now, making sure that the candidate has kind of a pipeline to understanding emerging skills and trends are involved in the community is an important thing we look forward to. So I have a question about digital engineering. So in terms of digital engineering tools, which one should a system engineering be proficient in? So there's a lot of digital threading type of tools that I would look into. Not like advocating one over the other, but Zendaya has one. SBE Vision is one. There's a couple things that allow you to do traceability across different data sets that I think is a big thing that we look for with digital engineering. Obviously, with focus in systems engineering, having some sort of requirements tool that you're familiar with, an architecture tool that you're familiar with, a T&E sort of tool that you're familiar with is a thing that we look for too. Anybody else have any experience with DE tools? All right. Any comments on artificial intelligence, machine learning? I think that this will be a really interesting area over the next couple years.
As far as this is Kaz, as far as the
Mhm.
DE tools, I believe about a year ago we had a gentleman describe a tool that he was working on for the chapter. So I'm certain that's still in our archives here, and maybe I can look that up right away while we're in the meeting here. But yeah, there was some tool set in order to, help with the confusion of various, you had testing, modeling, as well as simulation modeling, and you have the development of the model itself, and then you need to stitch it all together or remember how to, what flows into what and what version that were you using when you did these things. So it can be pretty tricky. So I guess I do recall that, but not the name of the tool. But let me look that up while we're online here.
All right, great. Thanks, guys. Yep, STK, ANSYS. So I think it also, digital engineering is pretty broad. So if you're looking at digital engineering as a career or a focus area under systems engineering, I would also suggest looking at, what part of the life cycle are you passionate about, and then understanding the tools that can help with that. So STK more for like simulation things, but obviously traceability tools, architecture tools, requirement tools, depending on what part of the life cycle you want to focus in on. All right. So moving on to Agile systems engineering. So as a just quick definition, it's a process where systems engineers work in an iterative and incremental manner. And Agile came from the software engineering community, and they have a software Agile manifesto, and systems engineering modified it to have a systems engineering focused manifesto for Agile. So the thoughts here, the driving things underneath Agile systems engineering is individuals and interactions over process and tools, verifiably correct specification over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. So in terms of how this looks like with more traditional systems engineering, you break up the work incrementally. So work needs to be broken up into parts that can be verified at least mostly independently. And they look for iterations that are roughly 2 to 4 weeks long, and that you can verify the quality of the work product at the end of each iteration, repair major defects during that iteration, and for minor defects, plan that into the next sprint. So the way that this is planned is using a two-tier approach. So, during the beginning of the planning, you can do the upper tier where you try to figure out major work units and plan out roughly your iterations. And then before each iteration, you plan out the work within that iteration, which could be informed by the previous one. They use risk mitigation activities, which they call spikes, to improve and verify the understanding of an issue. If the risk of failure is too high, they'll go and replan the portion of the project affected by the risk. But risk management, like with traditional system engineering, is a big focus. And the idea is that you don't know everything at the beginning of the project, so you're in this mindset where you're ready for change. You have ability to replan, and risk might be one of those triggers to do that. So verify consistently. So, unit level verification, the originator can test the work product individually. So this might be done at the end of each iteration. You've broken up the work enough where you can verify something at the end. Then as you get more and more work products or pieces of work products together, you can do integration level sort of verification, where you bring together related work products to ensure that they're consistent with each other. And then finally, when you have, more things that can be viewed as a whole, you do system level verification, where you look at entire work products that are verified as one. Integrating continuously. So, you're bringing different parts of the work products or different work products together and verifying that they're consistent, and then validating frequently. So there's a lot of interaction with stakeholders to ensure that your work products are meeting their needs. And also, as you're learning more about the stakeholders' problem and learning more about, just the data of the system, you're doing that progressive refinement of engineering data. So why you would want to pursue Agile systems engineering. So improved quality of engineering data, early and continuing verification of engineering data and specifications, and true progress is the generation of correct worked products. Improved engineering efficiency, with the emphasis on continuous verification of engineering work products, which is the idea is that that's resulting in less rework. An early return on investment. So because you're getting that early feedback on requirements, you can demonstrate correct engineering data, and the specifications are actionable. You hopefully will see the return on investment of doing systems engineering faster than maybe in the more traditional approaches. Having satisfied stakeholders, because through improving the quality of the work products and working with those stakeholders through the process, they have a actual stake in the work. Increase project control by tracking progress against objectives rather than against a plan. So this gives an earlier indication when the project is going off the rails or when a plan is flawed, so that you can work to change the plan, which leads to responsiveness to change. So Agile methods handle change gracefully because change is expected. And then finally, earlier and greater reduction in project risk. So, metric of progress is a risk burn down list. It's used to work tasks and learn relevant information about risk and replan as necessary. So then in terms of hiring somebody with the Agile systems engineering skill sets, there are different Agile methodologies, Scrum, Kanban, and SAFe. The idea of continuous integration, continuous delivery, which also comes out of the software world, but how can you integrate in parts and give a deliverable, and then update things, integrate again and give another deliverable. Although collaborative teamwork is an important skill to have in general, it's really crucial with Agile systems engineering, because you're moving pretty fast. You need to make sure that everybody is on the same page and everybody understands what they're working towards in an iteration or sprint. So that's something that we usually look for in terms of skills. And then DevOps or even DevSecOps and system integration. So if you have all these, piece parts and all these pieces of tasking that you have broken up incrementally, you need to be able to bring that together. So in terms of, an interviewer asking a candidate questions about, Agile systems engineering, we're really interested in hearing their thoughts on when it makes sense to use an Agile paradigm. Hear about what are the trade-offs when using Agile systems engineering versus, a different systems engineering approach. And then, of course, there are the Agile standard methodologies, but you need to be able to tailor those methodologies for specific program constraints. So, a lot of times a methodology just doesn't work out of the box. So we like to hear about how somebody tailored the process, why they chose to tailor it the way they did. If they can understand, what they were maybe trading off or what they weren't going to see in terms of benefits by doing the tailoring, that's a great thing to hear as well. All right, and then my last trend is human-centered systems engineering. So it's an interdisciplinary approach that focuses on designing development and developing systems that prioritize human needs, capabilities, and limitations throughout the system lifecycle. So the principles that you really look for in human-centered system engineering is human-centered design, user-centered focus, and system lifecycle integration. Human-centered design really relies heavily on, human-centered design principles, emphasizing iterative development and user feedback at every stage. So the idea here is that you're really aligning the system with the user needs and context. The user-centered focus is designed to optimize usability, accessibility, and performance. And you can do this by considering physical, cognitive, and emotional human factors. And then system lifecycle integration incorporates user considerations from requirements gathering to ensuring continuous improvement and relevance. So then in terms of human-centered and, throughout the maybe more traditional system engineering process, you have, stakeholder analysis where you identify all the users, the operators, maintainers, any human that needs to interact with your system. And then you can do a task analysis phase where you understand the specific tasks that any user or person interacting with the system will perform and really understand the context in which they operate. Prototyping and testing is a key part of human-centered systems engineering because the rapid prototyping can be combined with usability testing, and doing that usability testing before the design is finalized can really help you refine that design to ensure that you're considering the human involved with the system. And then evaluation and feedback in terms of continuous performance evaluation, making sure that your system is meeting human performance metrics. In terms of goals, for human-centered systems engineering, enhanced human system performance goal, that ensures that the system supports optimal human performance by aligning with cognitive, physical, and sensory capabilities. Ensuring user safety and health goal, designing systems that protect user from harm and reduce physical and cognitive strain. Increased system usability, meaning making your systems intuitive and accessible and also easy to learn. Another goal is to minimize workload and stress. So we're trying to reduce the cognitive and physical workload to enhance user comfort and performance. Then promoting user satisfaction, which meaning ensuring that the systems are satisfying and engaging to use. And then we want to consider inclusivity and accessibility by ensuring that the systems accommodate a diverse range of users, including those with varying abilities and needs. So the idea is that by integrating principles, not only from engineering, but also psychology and design, human-centered system engineering ensures that systems are intuitive, efficient, and safe for users. Sean, for your question, I think human factors engineering and human systems engineering are along the same veins. What I've heard from like human factors engineering groups are focused on the same type of things with like ergonomics and usability and accessibility of a system. All right, so then evaluating somebody with the human-centered system engineering skill set. So understanding the human cognitive, physical, and sensory capabilities by applying ergonomic principles to reduce physical and cognitive strain, looking that they know how to conduct usability testing and heuristic evaluations. There's a lot of industry standards in terms of human-centered systems engineering. The ISO 9241 for ergonomics and ADA for accessibility. It's good to look for people who are familiar with those. For user-centered design, conducting user research, they can demonstrate that they've done that to understand needs or behaviors and context. Developing personas, scenarios, and user journeys. Also looking that they know how to do the iterative prototyping and evaluation with the end users to get feedback for the design. And then data collection and analysis skills. So are they able to design experiments to collect qualitative and quantitative user data? Do they have some statistical analysis skills in order to interpret the data that they receive from experiment in order to inform a design, and then conduct task analysis and workload assessments. So in terms of types of things we look for when we're trying to understand a candidate's understanding in terms of human systems engineering is understanding how to balance automation and human control. So as systems become more automated, we need to ensure that the human remains effectively engaged, which could be challenging. Multidisciplinary collaboration. So again, this is like a general important skill to have, but with human-centered systems engineering, you're also adding in, like fields like psychology. So, making sure that they know how to have some sort of seamless collaboration between people like engineers, designers, and psychologists. And then for scalability, having an availability to tailor those human-centered principles to different types of systems and stakeholders, because as systems get larger scale with diverse stakeholders, really following that human-centered system engineering manifesto can be more and more difficult. All right, so I kind of wanted to end this part with just some general hiring observations, no matter what maybe sub skill set you're looking for. But for all these things, like obviously you need a mastery of systems engineering principles. Systems engineering is still at the core of all these things, even though something like AI ML is a field within itself. But what I'm looking for is systems engineers first that have these other skill sets. So being able to talk about what part of the system lifecycle or in cozy competency that you are an expert in or passionate about is really important, and making sure that the people I hire are really grounded in the systems engineering principles. Problem solving and critical thinking skills. This seems very obvious, but it's surprising of sometimes how many people will just kind of follow something blindly or follow a methodology or a book without really understanding what they're doing. So I really look for people who question things, who given a problem they've never seen have, a way to move forward with that, even if it might not be the perfect direction, they have some ideas of where to start. So we try to pull out if somebody has those kind of critical thinking skills. As you saw throughout this presentation, ability to tailor. So there's a lot of academic resources for doing a lot of these things, but obviously in academia, they can't consider every single project situation or constraint. So it's really up to the systems engineer on our project to understand the constraints, in terms of cost, schedule, or technical performance, also the organization within you're working with. So you have to be able to tailor, things that are in academia to do some of these processes, things that are methodologies to be able to make sure that you're realizing, the benefits you expect to realize by doing, systems engineering or the specialty within. It's really nice to see, a demonstration of breadth across all the engineering domains, just because there's a lot of interaction with a lot of different engineering. And I think it's helpful to have depth in at least one engineering domain, just because if you have depth in one, you really relate to that team, and you also know what you're asking your team to do. And as you have depth in one, you've worked with, adjacent fields too, so you kind of understand the language, the challenges, things like that within an engineering domain. Leadership and facilitation, as systems engineers, we're usually leaders on projects, acting as the advocate as for the system itself. A lot of interaction with program management and stakeholders. So making sure people have at least leadership inclinations or can facilitate discussions, about system needs or challenges or things like that is helpful. And then I also look for people who want to continue to learn and grow. I think, as we've seen, systems engineering as a field is not static. It's not you go to school, get your bachelor's or master's, and you don't have to learn anything ever again. I think as technology improves, as things like AI, ML come on board, we're going to have to be in the mindset where we're continuously learning, different techniques of realizing the systems engineering discipline. So with that, there's just some references I pulled for this. And are there any questions or discussion anybody wants to have?
Yeah, I've actually got a question for you, Shannon.
Sure.
So first of all, excellent talk. Thank you so much for providing that. I did want to ask, so for all of those areas that you've mentioned, which one do you, which one do you feel you have the hardest time finding quality candidates for? And why do you think that is?
I have to think about that. So I can tell you the ones I don't think it is immediately. I think human-centered systems engineering has been like a pretty recognized sub-discipline, and there are like, system engineering classes and programs that teach that. So I don't think it's
Mhm.
that one. Agile systems engineering, I don't think it's that one because, the software Agile kind of process has been, around for a while. And especially people
Mhm.
who used to be software engineers that become systems engineers are pretty familiar with that. I think the difficulty with that is understanding how to incorporate hardware. Um,
Right. Right.
MBSC, I think is getting slightly easier.
Mhm.
It's I think it's just becoming more and more popular. There's more and more programs. We have our certifications, things like that. So that kind of
Mhm.
leaves me
Mhm.
with digital engineering and AI ML. So I think digital engineering is hard because it's still a pretty evolving field. And I kind of think I see like two kind of classes of candidates. Like one is
Mhm.
they're really high level in like the policy and like really familiar with like OUSD is doing and like some high level documentation, but they don't know maybe how to apply it or execute it to a problem. Like, we'll have a customer kind of come to us and say, we need to do digital engineering to, you know, adhere to this guide, but we don't know what it is and we don't know what it gets us. And somebody at like that super high policy level might be able to list you the benefits, but they don't know how to execute or realize it. And then I think
Right.
the other side I see a lot is kind of people that are really embedded in the tool world, and they have
Mhm.
their
Mhm.
tool suite that, they think can just solve everything, but they're kind of missing the point of why we're doing it.
Right.
So I think that one's hard to hire into, especially because, like, where I'm working, we're expected to be kind of experts and trusted agents in like these different fields. So to be able to answer sort of any sort of sponsor question is, I think, hard in digital engineering. And
Mm.
then AI ML, I think, is a little hard just because it's a field within itself. Like you can
Right.
obviously get a PhD as a computer science in AI ML. I think the use, it's been around for a long time, but I think the use of it for the general public is still pretty new. So
Mhm.
I think it's really trying to find people who are systems engineers first and, just want to do their job better or just interested in really complex systems with AI ML components, they've learned enough about it that they can use it. But I haven't found a lot of people that kind of have that blend. It's either, they're AI ML researchers or they're more
Mhm.
traditional systems engineers and haven't done like, taking the time to really understand what AI ML means for systems.
Yeah. Okay. Cool. Thanks.
Mhm. Great. Any other questions?
Yeah, Shannon, Dan O'Neill.
Hey.
Yeah, hey, so increasingly through schools or through taking the test, it's it's easier to get the ASEP than it was before.
hmm
Is that valued by hiring managers or just kind of a nice to have?
I value it personally.
Okay,
I think it tells me a couple things. It tells me that you should know at least depending on what level, right? Like
yeah,
ASEP, passing the test, right? You should know the systems engineering fundamentals. CSEP, and definitely ESEP, you should be able to really apply systems engineering and have some sort of demonstrated track record for that. So I think for me, because I get for some of my requisitions, I get hundreds of resumes. So sometimes when people have that certification, it kind of highlights their resume to me versus everybody else, right? Just because I know that they've taken the time and invested in themselves to get that certification. And by passing those tests and also having the references for the higher level certifications, they have demonstrated some level of understanding systems engineering fundamentals and applying it. I'll say, like, that alone, I don't think gets you the job, but I think it definitely makes it more likely that your resume gets looked at. And you have that phone screen where you can then really highlight your skills.
thank you. That's very helpful. I mentor some people and I'm like, gee, what else can I do to get the job? And I'll add certification to my list. Thank you.
Yeah, and I mean, being involved within Cozy, we're pretty familiar with what that means. So I know, like, one of the things we try to ask in general for system engineering is, there's I forget how many in Cozy competencies, maybe around 20, and we ask them like, which ones are you passionate about, or which ones do you have the most experience, or which ones do you want to grow in. So having that basis of understanding of what those competencies are, and the questions that are asked by the test, I think are also valuable.
Thank you. Yeah,
Mhm.
I'll add that to my little shtick with my mentees.
Yeah, and more and more programs, master programs, are having the ASEP equivalency. Like, I know Johns Hopkins University just got it for their intro to SE class. All right.
Hey,
Any other
Shannon.
question? Yeah, go ahead.
Um, Not a question, but Dave Flanagan is online, and
hmm
I kind of chatted with him in the background, and it he found a script for administering oath of office, and he volunteered to provide the oath for you and Risa and Sam, if you
Perfect.
guys want to do that.
Yep, I'm good.
Unless there are any questions for Shannon first.
Yep, and feel free to reach out if you want to talk more about this. I think it's pretty interesting. A different way of looking at some systems engineering trends is how would you hire these skills? So happy to talk more if anybody's interested later.
Awesome. Thank you.
All right, Dave, you want to take it away?
It's